Okay, so continuing on with this discussion of our normal curve. So whenever we look up z equals 1, we were just about to describe what that really means. Z equals tells you how many standard deviations you are from the mean. Now that's going to vary depending on our data. You know, we talked a lot in the last section about how to figure out a standard deviation. So it depends on the numbers and how varied the numbers are from one another. So you can calculate the standard deviation old style by taking every number and going through that tedious formula, but you'll be glad to know in this section they give you a break on that, and it usually says a standard deviation is yada yada. It gives you that calculation, so you won't have to muscle through that. But whatever your standard deviation is, when you do z equals 1, you are one standard deviation above the mean. If we do z equals -1, we'll be one standard deviation below the mean. All right, so we were talking about this chart that's in your book. It's a mighty chart. It looks like this. All right, and it tells you, and it says the description in the heading, this is the table of areas to the left of z, and it's got a negative value scale because sometimes z-scores are negative when you're below the middle, and sometimes z-scores are positive, like over on the next page. If I can show you that. On the next page, we've got the table of areas to the left of z when z is positive. We really could just use one table because it's a symmetric, and some books kind of do it that way, but our book does not. It gives you both sides of the story, and it tells you the total area from whatever your z-score is, shouldn't be writing in my book, and then all the way to the tail end to the left. Again, it describes it as the area to the left of z. So it tells you this area, which is a whole bunch, it looks like from there. So we're looking up z equals 1. So we look up 1.0, and then the to the hundredths place. This tells you whether there's a value in tens place or hundredths place. So I'm just doing regular 1.00. So down that first column, notice that value, 0.8413. That's the value we're talking about here. That means from z, if z is 1 to the end, we have as a decimal 0.8413. Now, it's probably easier to kind of consider that as a percent. In our minds, it helps me to imagine what percent is that. So move it to right, makes it a percent form. 84.13% of data is from this z is 1 to the end. If we were doing z as 1.10, we would say it's even further over here. You know, z point 1.1 would be even further past 1, so we'd expect it to be a larger percent, and so on and so forth. When you get to z equals 2 standard deviations, you know, really you're taking in most of the curve. You know, we're taking in account not very many outliers past that. So when you look up z equals 2, 97.72. So 97.72% of the data will be at the second standard deviation and then to the left. So that's how the book works. If you were looking up the z-score, let's say of 1.13, for example, we would look up, and that's positive, so we'd need the positive scale. 1.1, you do the first, you know, two parts there. The 1.1 would be down this left-hand side. 1.1, and then that's 1.10, and then 1.11, 1.12, 1.13. So this gives you that 3 in the hundredths place. So you'd see where those intersect. 1.1 and then 3 would be 0.8708. 0.8708 would be your answer to that. If they ask you to answer it in decimal form, you'd leave it like that. If it requested with a percent, you go to right and change it to percent. All right, we'll come back to that in a bit. But back into our note packet then, I'm on the second page here and talking about your z-score. We're saying when z equals 1, how that's 0.8413. That means that 84.13% of the data will fall below one standard deviation, and that is most of it, right? That's the big bulk of it. So for an activity, I want you to draw the normal curve and label what I just did. Just kind of repeat that to see if you can have a visual of that. So as always, you can pause the video, but I'm going to keep on showing that here, what I'd like you to have in your notes there. I always show where the middle is. You really don't have to show that, but it just gives me kind visual, that's straight down the middle, that's where the mean is, and then 1 standard deviation is somewhere over to the positive side of that. It's kind of arbitrary exactly where you make, because it depends on you know, of your data and everything. But 1 standard deviation is somewhat above the middle, and then I shade in the, it said draw the normal curve and label z equals 1, so that's z equals positive 1, and then shade the 84.13%. And that 84.13% comes from finding z equals 1 is 0.8413, and that's the area to the left of your z-score. So it takes it from your z-score all the way out to the tail end of the curve. And that's what you should see for your labeling below. Okay, on the next page. So back to our baby example. I know you all were curious about that earlier. So we were talking about the baby example, how that there's kind of an average birth weight, and that may vary between years and times, and you can look up. I'm going to use a birth weight, the mean birth weight as 7.5 pounds is the average birth weight, or the mean birth rate. And the standard deviation is 1.125. So that's kind of a big deviation. I'm not sure that's absolutely current information or true. So if you had a 9-pound baby, how much of an outlier were you? How far did you vary from the norm? You would add what it said, 1.25 is the standard deviation. So at z equals 1, how much would that baby weigh? 1 standard deviation above the mean. And you could figure that out by 7.5 plus 1 standard deviation was 1.25 pounds in this example. This is the first time we've had actual numbers given in this section. So if you had an 8.75 pound baby, you would be at 1 standard deviation above the mean. That's pretty baby, right? And that would be 84.13, like we talked about earlier. You'd be in the 84th percentile, right? That's pretty good. Well, what if you had that 9-pound baby? That's even further over here. I'm not exactly sure how far it is over there, though, because this does not allow me to put in 9-pound baby. Notice when you look at the z-scores, oops, I'm new to this. When you look at on your z-score chart, there is not a 9 on this page. There's only 2 pages, right? If I turn the page, nope, no more z-scores. So there's only these 2 pages, and it only goes down to 3.4. And even at 3.4, if you can see this, it's at 99999. You know, you're almost to 100 there, 100%. So there is no 9 down this score for Z. So you cannot use the raw data. We'll call 9-pound baby a raw data example. And raw data is not in our chart. We have to convert it to a Z-score. All right, so we're ready for a new formula. The Z-score formula, is right here. To convert raw data, like our 9-pound baby, into a z-score so we can then use our table of values, you take the value of your data, which that's the 9-pound baby, subtract the mean, which was 7.5 pounds, and they'll give you those things in your problems, and then divide by the standard deviation. Again, that was given in your problem. So that's your calculation. Whatever your piece of data is, or your raw score, raw data, the 9-pound baby, minus what it states is the mean, divided by your standard deviation. Punch that in your calculator. I've done this here. You knew it was a little more than 1 because you're a little heavier than 1 standard deviation. So that's 1.2. So your 9-pound baby would be at a z-score of 1.2. So again, if I want to draw that little curve to death, right? I'm above 1 standard deviation. I'm at z is 1.2. I'm a little more than the 84th percentile, right? What percentile is it, though, you want to know? So how do you find that percentile? That's what your chart is for. Now you look up 1.2 on your table of values, and it looks like 1.2, 0. There's no other number there, so it's assumed to be 0. So back to the book, go down your chart, look up 1.2. This is the 0 value, right? So that's the first place, 1.28849. 0.8849 is our value. So, and that's what I've got here in your notes, this 8849. That means that a birth weight of 9 pounds is 88.49%, or the 88th percentile. All right. Shoo, right? That was really the big deal to get through in this section. That's going to help us proceed, being able to find these z-scores and then use the chart. So if you've got that, we are rolling. We're going to practice that a little bit though. So I have some activities. Again, pause the video to practice these on your own before I reveal the answer. But I'm going to take, what if you had a 9.3 pound baby? 9.3 minus the mean is 7.5 divided by 1.25. Oh, I've got to calculate that. I meant to have that already done for you, but I did not. Okay, 9.3 minus 7.5 divided by 1.25 is 1.44. Now, we're supposed to look up the percentile, so you've got to go over to your z-score table now and look up 1.44, which gives you 0.9251. So you're almost in the 93rd percentile there. Okay, again, 7.2. Now you're a little below. These are going to be below negative z-scores. So how do I do 7.2? I do 7. I want to make that dash. 7.2 minus 7.5 divided by the standard deviation. So type that on my calculator. And it gives me a negative value, right? And we kind of feel in that, if you're following along with me, you should have kind of anticipated a negative because we're below, right? The mean is 7.5 pound baby is the average. So if we're having a 7.2 pound example, we're below. We're at a negative z-score. So when I calculate that, I get negative 0.24. So then I get my table of values. So now we get to use that negative side. Negative 0.24. That's all the way. Oh, where is that? Negative point. Oh, can you see that? Oh, it just barely fits in the screen. Negative 0.02, and then that's the 0, 1, 2, 3, 4. 0.4052. Still can't see it, can you? Oh, there we go. Negative 0.2, 0, 1, 2, 3, 4 is 0.4052 is my answer for that. 0.4052, which would be the 40.52 as a percent. You know, you just have to move it to right. All right, one more. 5.6 pounds. So now we're getting even further over here. So it's going to be even more negative, if you can think of it like that. So calculate 5.6 minus 7.5 divided by 1.25. So calculate that away. And you should get negative 1.52. All right, so again, look that up on our chart. I hope this isn't driving you crazy, this back and forth here. You'll have to do that with yours too. Negative 1.5, and then that's 0, 1, 2. Should be this value right here, 0.0643. 0.0643. All right, and then as a percent to right, that's 6.43%. Now, next we have some practice just looking up z values. So I ask you to look those up. Again, pause the video anytime. I want you to practice these. The practice is important. I'm going to write out these answers. If it asks for the answer as a decimal, you leave it like this. If it asks for it with a percent sign, you know we've got to move it to right. So you'll find that both ways in your homework. Notice the z-score of 0. 0 is you're right at the mean. You didn't move from it. You did 7.5 minus 7.5 divided by 1.25. You know, if you're doing the number that is the mean and subtract the mean, you get a 0 on top. So that's why a z-score of 0 would be right down the middle. So that's 50%, right at the 50% line. 1.80 is 0.9641. 2.78, 0.9973, 0.81 is 0.7910. Now practicing some negatives. Negative 1.2 is 0.1151. And lastly, negative 1.34 is 0.0901. All right, so check your work there and hope that helps.